Hello, everyone. My name is Crystal Shaughnessy. I am the event specialist here at EDB, and I will be your host today for our webinar on cloud migration paths. I am joined by Bruce Momgen, Vice President and Postgres Evangelist at EDB, as well as EDB's Chief Technology Officer, Mark Linsta. Before I turn it over, I'd like to just review a few housekeeping items. Firstly, the presentation is being recorded, and we will be sharing the recording along with the slides after the broadcast. Secondly, please note that the lines are currently muted. We expect the presentation to last most of our time today, but we will allot any extra time at the end for Q&A. So if you do have a question, please feel free to submit it into the question panel. If for some reason we do not have time to address all of the questions, we will follow up afterwards with any attendee whose question was not answered. So with that, I will hand it off to Mark and Bruce.
All right, thank you, Crystal. All right, so what we're going to do today is we're going to talk about different cloud migration paths. And I know we have actually a lot of people signed up for the webinar. So also, please don't be shy with your questions. Bruce and I will have time at the end to go through them. The way we're going to do this today is going to be more of a discussion. We don't have a ton of slides here, but we want to talk a little bit about why people are leaving legacy databases, why enterprises are moving to the cloud, because both of those will help answer the question, okay, which cloud service or what kind of cloud are you really looking for? Okay, we're going to define a little bit what a cloud service is, look at that cloud options, and then discuss a little bit about Kubernetes and DBaaS and virtual machines and some key considerations that have been derived from what we learned over the last couple of years working with customers who went to the cloud. Okay, so the way we're going to do this is, as I said, we're going to start understanding a little bit about the whys, because that really drives the places where folks are going to end up. One thing we're not going to do today is we're not going to talk about Enterprise DB at all, right? If you want to learn about who Enterprise DB is or so, I suggest take a look at our website. Today, we want to use all the time we have to talk about cloud migration path. So let me start first with Postgres. I mean, Postgres is the clear winner in the database game, right? I mean, it's like everybody knows that today, but I want to just reiterate some of the statistics here. And Bruce, please chime in. I mean, there's an important story in these 4 data points here. First is DB Engine's ranking is for three times in the last couple of years named Postgres as a database of the year. That is really talking to a crowd of DBAs. That's where their questions come from. That's where their rankings come from. It's questions about how to use a database. So that's the first thing. You'd say, hey, that's a conventional audience. Hey, Postgres, they like Postgres, right? Well, then you go over and say, hey, Stack Overflow, the developers. The developer survey shows that Postgres by far is the most loved, most wanted, most popular database out there amongst developers, way ahead of databases that you would think you would find in the #1 position, like Mongo, for example. Okay, so then you say, okay, it's developers, okay, that's still old stuff and stuff, and then you go on and look at Docker containers, and you see in Docker containers, it's also the #1 real database. I'm not counting Redis because I don't think Redis really is a real database. So it's the #1 in containers. Okay, that's for new technology. Then let's go to the ultra new stuff, like the Cloud Native Computing Foundation. Let's look at their Tech Radar. And again, Postgres is the #1 real database on the Tech Radar for the Cloud Native Computing Foundation. I mean, again, Redis and Elasticsearch, I don't really consider them databases. Maybe I'm biased, but I think they're much more in-memory cache or search engines. But there's a real story here that drives the success of Postgres. And Bruce, anything you want to add there?
Yeah, it's really in some ways a bizarre story for me, having started 25 years ago as a when Postgres really would never have been on this map. To see it grow, even I'm thinking of milestones like I guess it was 2000, 2001, Fujitsu headquarters. And they wanted to do something to Postgres. They want to add some features, and I'm thinking, why is, this is probably 5 years in for me. I'm like, why does Fujitsu care about Postgres? Like, doesn't make any sense, and then you start to see, IBM promoting it, and then, you start to see a lot of big banks and then credit card companies, insurance companies using it. And then, you start to see all the big IT companies using it, all the big web services and, software as a service, and then now all the cloud providers. And then you start to see numbers like this. And, the relational database is always a long game because it's so hard to switch. So it's really taken a long time to get here. But the cool part is you'll probably, based on the kind of momentum we have, we're probably going to stay here for the foreseeable future, as far as I can tell.
And a piece of data that Bruce and I are not showing here is when you do the trend analysis, for example, for Stack Overflow, you can see that Postgres has been growing over the years and is growing faster than anybody else, right? So there's a net decline that you can observe with other databases and the net win that is actually accelerating on the Postgres side. So why are enterprises leaving their legacy databases? Well, there are some high-level reasons that are always given, like price, but I don't really believe it. And Bruce, I think I can quote you when you said, if it was just because of money where people would come to Postgres, they'd come to the Postgres conference once, right? And then they're on Postgres, and then they're done. They'll never show up again. The thing is, what really drives it is agility, innovation, and the future-proof aspects. Because that's why people come back to Postgres. They don't just get onto Postgres and then say, check, done, I'm moving on. Then they're seeing the true potential of what I can do if I have a database that I can deploy everywhere. A database that has more data types and more GIS capability, more JSON capability than anybody else. A database that's now getting into graph compatibility. So there's a tremendous thing to be said about Postgres, even though the high-level argument often is, hey, it's cost, Oracle's too expensive, let's go somewhere else. What really happens is, they start looking and then they say, wow, this is pretty cool stuff.
Yeah, I've always been kind of stumped by this. Why has Postgres really staked out that high ground compared to almost every other relational database out there? And I've actually had to write some talks to try and explain it to myself and explain it to others that the one will Postgres live forever, and democracy, data democratization of databases. Both presentations on my website with recordings really kind of go into that, Mark, trying to talk about, you're right, price is why they come, but innovation and agility and reliability and flexibility are the reasons, and those non-relational capabilities, those are the reasons they stay. And I'd love to think that the Postgres community is a genius, and we figured this out years ago, and we realized this is where it was going to. Well, not really. We just kind of did what we thought made sense at the time, and took the opportunities. And the open source process itself kind of took care of getting us in this position. And I think as long as we allow it to continue and unhindered, we're going to stay in that good position, because all the other relational databases are incredibly rigid in how they're developed, and how they set timelines, and how they set roadmaps, and how they position the product. And Postgres, because we've got companies, not only EDB, but companies around the world working regularly to improve it, we're continually getting that innovation, often before people even know they need it. And I think that is a testament to the open source process, the way the community has sort of shepherded this project for so long, and we're seeing the dividends here.
Yeah, and I think when we now try to tie all of this together, right, we're saying, hey, enterprises are moving. Why are they moving to the cloud? Okay, now we see these themes coming together again. Like, we still have agility and innovation. We have cost that are still in the picture, but agility innovation is really what drives it. I mean, a customer of ours a couple of weeks ago told me today it takes us 52 days to provision a new database for production. That has to come down to hours and minutes. And I think that's one of the best articulations of what agility really means, right? Because if it takes that company 52 days, that means 52 days of inaction, 52 days of waiting, 52 days. This was a financial services company, 52 days to for some other fintech or neobank to just pass them by, right? And that's one of the reasons they do come to Postgres and to the cloud. And then they want consumption-based licensing, right? Because the big thing about consumption-based licensing is if your project doesn't work out, it's okay. With normal licensing, you have to spend millions and then you find out, oh, well, this wasn't the right choice. What are you going to do then? Well, you're going to continue with your wrong choice because you have no way back, right? So agility is not just coding agility. Agility has a lot to do with the ability to do new things quickly, which includes coding and going to the rest of the business process. Innovation. Bruce talked about it already. It's like it's the thing. It's the lifeblood for so much of what our customers are doing today. Income to other factors: global markets and data center closures. Right? With with digital transformation, we're going into global markets. Well, you can't serve customers in New Zealand out of a data center in, let's say, on the West Coast and think their customers are going to be happy with interactive traffic. You got to get close to them. Well, in the old model, the only way to do that was to go build a data center in New Zealand. That would take even longer than the 52 days, and it would cost a fortune. And if the market in New Zealand wasn't panning out, well, then you'd have a building that you have no use for. So this is also an aspect of agility and the ability to change very, very quickly. Okay, and then the last thing that we're hearing again and again is customers don't want, or CIOs don't want their resources to be focused on non-value-add activities. And racking, stacking, installing, patching, burning in, all that kind of stuff is not really a value-add activity. It's necessary, but it's stuff that today is just being outsourced to cloud service providers. And Bruce, anything you want to add on that?
Yeah, and we've, you know, as a database project, obviously we've seen cloud, we've seen containers come, years ago. And what was really interesting is that agility term you talked about. And we always heard agility as database people, we always heard it as, oh, you start the service, you destroy it, you do, and we always looked at it. We're like, wow, this is a database. We don't want to be destroying, we don't want to be destroying our data because it's got the need for persistence, right? Which a lot of the early talk about cloud didn't really focus on. They talked about app servers and web servers and sort of sending multimedia at different places, and that's great, for cloud. But we kind of looked at it. We're like, oh, I don't know how really cloud really fits in, because the majority of things they were talking about really didn't apply to the kind of markets at database. But what we've seen in the past recent years is the idea that obviously creating a database and then destroying it in a day is probably not a fruitful exercise, but the ability to co-locate databases in different places, the ability to automate the install of those databases so you don't need a huge IT team to do that. The ability to scale the size of your database up during heavy workloads, right? Sort of Christmas holiday shopping, case, which is why Amazon got involved with the scaling in the first place, and sort of brought this whole cloud concept. So those things really do resonate for a database, right? So we've had to kind of carve out, okay, cloud brings all these things. 90% of them, 85% of them don't really apply to a database, but some of them do. And what we're seeing now is, you're right, the automation of that deployment, the geolocation of that, the additional reduce staff necessary so that people can focus on the more value add things that they can do versus the more mundane or audit stuff that can be automated. And you're seeing this across the whole industry, and obviously this is something that really resonates now with companies. Originally, the idea of taking a database that has customer data and putting in the cloud was, a lot of companies early on said, no, we don't want to do that. But now I think as it's matured and people understand where the value is and where the value isn't, you see a lot more of this kind of movement. The good news is that technologically, Postgres really didn't have to make any changes for the cloud. In terms of the technology itself, the software, we were already easy to deploy. We were already data operating system agnostic. We already were very lightweight. So, there really wasn't a whole lot of work. Yes, there was needing in tooling and sort of deployment stuff around the database, but the database itself really didn't have to be changed almost at all to go into cloud.
Yeah. So let's take it now to a poll. Our first poll in this webinar. Crystal?
Yes. So the poll question is, how are you moving your databases to the cloud? First option being Postgres VMs or infrastructure as a service. The second is Postgres containers with Kubernetes. And lastly, fully managed database. So I'll give you just a couple more seconds for those answers to come in.
And we'll share these results with you as part of the slides that will be distributed afterwards. So again, if you want to take this home, and we also have another poll here that is currently running on LinkedIn that we'll share with you too, just for other information about what everybody else is doing, what are the current trends. So how are we doing?
All right. So
It's
managed.
split in three there.
Yeah. Yeah, it's interesting. I mean, it's this is very similar to what I've just seen on the LinkedIn poll. Crystal, can you bring that back?
Oh, sure. So sorry.
That I've just seen on the LinkedIn poll, and it's interesting that we're not seeing more of a skew towards the fully managed DBaaS. But those are really the three interesting options that we're seeing today in the environments, and we'll talk a little bit about the pros and cons about these.
Yeah, that's the good news, is we're going to be sort of splitting these out to talk about when you might want to use these, so that the cloud is one thing, but how do you deploy it? That's the big question.
Correct. Okay. All right, so going forward here's a poll that I started, I think a day or two ago on LinkedIn. Encourage all of you to, look for it and add to it. Here we're seeing a little bit of a different distribution, right? Here in the poll that we just had in this webinar, it was the virtual machines on infrastructure as a service were very high. Database as a service was a little bit lower. We're seeing a distribution like this actually quite a bit, where there's a strong push towards database as a service. I must say, when I'm looking at this, I was a little surprised about how strong Kubernetes and containers are as a cloud platform. Okay, and again, this will be part of the slides that we'll share with you afterwards. So let's talk a little bit about the three options for Postgres in the cloud. The question is really, which is the right one for you? And one thing I want to emphasize here is there is not necessarily one right choice. We have customers who use all three, because all three have their justifications. And all three, have a reason to be used. I would not say, oh yeah, if you go to database as a service, forget about containers, forget about virtual machines. No. There's many situations where actually you use all three, not on the same project, but as part of your strategic going forward plan. So just to put that a little bit into the EDB context, a virtual machine on infrastructure as a service would be a Postgres VM with a virtual machine with EDB failover manager or rep manager or Patroni, right? And then something like Postgres Enterprise Manager to monitor these things at scale. So here you would typically use something like Ansible or Chef or Puppet or Terraform to install these machines, configure them correctly, get them up and running. It's a very, very quick process, and you can automate these. I mean, we have Ansible Galaxy. We have predefined scripts that you can find under EDB Postgres that do that in about 20 minutes, configure a complete cluster for you that is ready to be up and running. Okay, so some aspects of cloud you can actually do this way. Then the other option is use Postgres containers with something like EDB's cloud native Postgres operator or the operator provided by Crunchy or by Zalando, etc. So that's another option to put Postgres in the cloud. And for that, you can use, EKS or AKS, GKS, all the Kubernetes services that are out there. Or you can use Postgres, the Postgres database as a service. So then it's a fully managed database service that somebody else actually operates and runs for you. Okay, and that, based on the statistics that we saw before, seems to be by far the more popular option. Okay, options here are the well-known, AWS's RDS for Postgres, or Azure's database service for Postgres, or from EDB, Big Animal. Okay, Bruce, you want to add anything to that?
Well, I think what this shows me really clearly is that you have to have for an enterprise, you kind of have to have a given level of service reliability, right? And functionality. So that's going to be the database, plus it's going to be some monitoring, it's going to be some failover, it might be some scaling, it might be some management, but you're going to have the database and you're going to lay stuff on top of it, right? So for the virtual machine case, you're controlling everything, right? You're putting the database on, you're putting on the failover capability, you're putting on the monitoring capability, the management capability, and the backup capability, and that's going to be all you, right? For the second one, the Kubernetes and the containers, in a lot of that case, those pieces are automated for you. That was the real value, I think, to containers for a database, not quick destruction and creation so much as automating the tooling around the database, right? And that's coming with a lot of your Kubernetes on top of the containers, right? Containers themselves give you part of it. The Kubernetes kind of gives you the management on top of it. And then the third one, obviously, database as a service, is basically saying, I don't want to install the database. I don't even really want to be involved with the that tooling on top of it. I don't even want to see the containers, right? I want somebody to manage them, and I want them to be checking the backups, right? So it's really a dial of how much you want to control and how much you want to give that control to someone else and pay for that service.
Yeah, it's really, I mean, counterclockwise in the circle here, you see there's more and more or less and less that you need to do, right? When you run virtual machines, you do everything. When you do operators, now the operator provides installation and a lot of the lifecycle support for you that, with virtual machines, you do that with Ansible, but Ansible really doesn't support a running database, meaning making sure that a backup happens, that a failover happens for you, that an upgrade happens. You can make Ansible do these things. Yes, it's a Turing machine, but it's not really in the nature of Ansible. When you then go over to the operator, now the operator, depending on the maturity of the operator that you chose, but let's assume it's a level 5 operator, which is what you can get today, then you will see that installation, upgrade, failover, backup, recovery, monitoring, reporting, all of those things will be taken care of by the operator. So the operator starts doing a lot more for you, but as always is, when somebody else does work for you, you give up some control. You have to trust them that they do it right. Okay, so you step back more and more from the responsibilities, but also from the flexibility. And then you go over to the database as a service. And now, as Bruce said, you have somebody else doing all the work for you. So yes, you've given up now almost all the control, but it also means you can focus completely on the innovation aspects. Okay. So that's why it's really important to understand these options and put them in the context of why you're going to the cloud, right? Because you have to understand, what are you trying to do? Are you just trying to get out of your data center? Well, maybe virtual machines are what you need, right? Are you going to microservices and re-architecting things differently? Well, Kubernetes may be the way to go, right? Are you completely focused on having everybody focus on innovation and, running it is something that somebody else should do? Well, maybe database as a service is the way to go. Right? So that's really the level at which we want to have this conversation, because we know that these are the important distinctions. So under the hood, this is the dichotomy. Okay? You can run in the cloud, or you can use a cloud service. Running in the cloud is really, you use somebody else's outsourced infrastructure in terms of compute and network. They make sure that all of that stuff is there. They are responsible for what I would always call ping, pipe, and power. They have to make sure that the servers are up and running, that the networks are there, that you can reach them, etc. So, which is already a great help, right? Because today, otherwise, you have to order servers, you have to configure them, rack and stack them, burn them in, all that kind of stuff. Here, somebody else does all that for you. On the other side, when you use a cloud database service or any kind of cloud service, then somebody else provides that service to you. You don't actually add and remove servers anymore. You add and remove databases. On the left side, somebody runs the network for you and the compute infrastructure for you. On the right side, somebody runs the databases for you. They make sure that the database is up and running, that backups happen, patches are applied, etc. Okay, so really it's an infrastructure that you're using or a service that you're using. And again, it depends a lot on how much control you want to surrender or how much control you still want to have and how much you just want to get rid of. Okay.
I guess
So,
the point you're trying to make here really is that even on the left-hand side, even if you're using containers and Kubernetes, you're still choosing what containers to use, right? So you're at least, that's your choice. Whereas I guess on the right, there really is no choice. You use the service as it's provided.
That's correct. Yes. So and you have a whole lot less control over what is being done, but at the same time, control means work and responsibility, right? That if you give somebody else control and you trust them, then you can shed that responsibility, you can shed that work and focus on something else, right? Okay. So what do most enterprises want? Well, they're actually looking for, what I would call the essential characteristics of a cloud service. And Bruce and I, we didn't invent those. This is actually defined by NIST, who I always find an interesting resource for clear-cut definitions. And when you look at what they're saying is the characteristic of a cloud service, it's on-demand, broad network access, resource pooling, rapid elasticity, and measured service. And when you think about it, what drives enterprises to using a cloud service, it is these 5 things. On demand, which basically means, hey, my VP who told me before, today it takes me 52 days. That's not really on demand. I mean, maybe it was on demand at the times of, in the Middle Ages, when it would take 52 days to do anything. But now on demand means like 15 minutes. I want it now. It's the age of Amazon, right? I want things to happen immediately. Broad network access, right? I mean, they're in the cloud, so you just should get to it from a mobile device, a laptop, anything. Resource pooling is a really, really important element. Okay, it's also one of the key differentiators between doing something with virtual machines and Ansible or doing something truly in a public cloud where you can use a lot of resources. If you don't have a large pool of resources, flexibility up and down and on-demand service is really, really hard to do, because on-demand service requires resource to be available like right now. So you have to have a relatively large pool of resources to be able to do that. Rapid elasticity is just the other aspect of that. I want more, I want less. I want it in New Zealand today. I want it in Germany tomorrow, right? That's the kind of capability I need to have. Again, my pool needs to be relatively large. Now, the last one, measured service, that's sort of like the emergency brake. Because if all you have is great flexibility but no measurement, well, your cost and your resource consumption is going to go through the roof. Okay. So these are really the aspects of what most enterprises are looking for when they go to the cloud. So go ahead, Bruce.
So yeah, I think that the thing that really comes across to me just looking at the slides is the issue of, do you want you know, do you have enough experience in-house to become an expert in all of these things, or are you going to be better off, and is it more cost efficient to pass that off to experts? Certainly, if you're using cloud infrastructure, you've passed off the hardware aspects and the configuration of the networking to that provider and the power, requirements. The question is, how much of that do you also want to, how much of the data management do you also want to pass off to them?
Yeah, and then we have customers who want to build an in-house cloud, provide
Yep.
build an in-house cloud so they can provide a cloud service to their business. We tell them, hey, this is really what your customers are looking for, on demand. Oh yeah, they say I can do Ansible. Well, sorta, kinda. Yes, it'll do the provisioning and do the decommissioning. Okay, but is it actually going to operate the system for you while you turn your back and you're off doing another task? Is it going to make sure that the backup actually completes and that it was written off to some kind of object store? Well, okay, maybe not. So that's the first limitation. Do you have a large enough resource pool so that when somebody says, I need more, you can actually provide it? Well, okay, that's going to be more difficult, right? Do you have the rapid elasticity? Can you provide the measured service so you can build the right departments, etc.? So this is an important roadmap when somebody thinks about what they really want and how they can provide it. So let me tie that a little bit back to what we talked about, infrastructure as a service, Kubernetes or DBaaS. Which one is a true cloud service? Well, my point is that virtual machines with infrastructure as a service are not really cloud services. A provisioning script like Ansible will allow you to provision things, right, or any kind of infrastructure as code, but it doesn't really help you operate everything on demand. You still have to look at, did my backup finish? Where did my files go? Is everything working? Etc. So it doesn't really meet the definitions of being on demand and self-service. Kubernetes is getting closer. As Bruce said before, the operator takes over significant responsibilities that today a DBA is doing manually or with bash scripts and other things. Okay, so as the operator gets more mature, going from just installing to the full life cycle up to autopilot levels, Kubernetes is taking care of more and more of the work. But what's really important is Kubernetes only controls the software, not the underlying hardware. And when you do provisioning, when you need more or less or a different geography, it's not just software, right? You also need to look at hardware provisioning. And then when the service is running, the service dependability depends on the hardware and the software. And again, Kubernetes is more limited in that. So what's often called the control plane is not there. And that is really necessary to provide a fully managed service, okay? And the database as a service, as the name says, is really the best solution to provide everything that you typically would call is a cloud service, because that will give you the self-service, on demand, the metering, etc. Okay, but as Bruce said, there's a strong trade-off between self-service and control, and we'll dig into that a little more.
Because you may not want a cloud service, right?
Yeah, you may not want to go all that far.
Yeah, because and I think of a lot of the enterprise database, they usually get created. It depends on what your architecture is, but in some ways, if you think you're going to need rapid scaling, if you think you're going to be provisioning a lot of stuff and destroying it and sort of moving stuff around, then yeah, you probably need a cloud service. But If you're going to be a more static kind of deployment, cloud service may get in your way. It may restrict the options you have. It may, prevent you from really doing value add for your enterprise. Specifically for maybe different ways you want to provision things, different, workload tuning you want to do for your site to have certain resources that are more important for your kind of workload than somebody
Hmm.
else. It could be just much more costly to do it as a service,
Yeah,
right? So it's not the service is always better for every workload. It's just a
correct.
question
Yeah.
of making that distinction. I need a service. I don't need a service.
Correct. Yes. Yeah. Sometimes your needs may be such that there is no existing service providing them. And in that case, don't try to cram everything into whatever is defined. You may need to do the work yourself. Okay.
And the services are usually more expensive, Mark. Is that
Oh
right?
yes, yes, they are usually. You do pay for that, right?
Is it like
For that.
double, I think, or something like that,
Well,
roughly?
it depends on how you factor in your in-house DBA
That's
cost,
true.
etc. Right? I mean,
That's true. Yeah,
you know, if
that's
you
true.
if you have a data center and if you have somebody running it and you look at the incremental cost for one server over 3 years, well, I'm not sure if going to the cloud is actually the better thing to do. If you then look at, okay, it's going to take me 50 days to get that server, and in 50 days I would have made, I don't know, per day $20,000, well, then maybe my cost of lost revenue is worth going to the cloud. So there's all these factors that you really have to figure out as to what you're going to do. I'm going to touch a little bit on the configuration capabilities, control capabilities, and the trade-offs in a minute.
There's one more thing, Mark,
Yeah.
that I think you and I've heard that, organizations are saying we're going to move everything to the cloud and we're going to remove that. We're going to reassign those staff who were managing it. So a lot of cases you're kind of right. If you incrementally are moving to the cloud, those services may appear very expensive, but if you think ultimately you're going to be moving everything and therefore those positions are going to be redundant, then you are starting to look at salary savings, and then you're offsetting salary savings against
Mhm.
the
Yeah.
cost of the cloud. And that's it gets very interesting, also very scary, certainly for DBAs of where their value is going to be in the organization. But
Right.
that's where things are going, and I think that's a really interesting question. You're right. One or two has one cost calculus. Moving everything has a different cost calculus.
Correct. Yeah. Yeah. And so really understanding what the trade-offs are is important for everybody. Here we're trying to highlight these a little bit to say, hey, here are the 5 NIST characteristics and which model really meets them and why not. Okay, just a summary of what we said before, that VMs on infrastructure as a service, even if you use infrastructure as code like Ansible or Terraform, they're not really on demand, right? Because you still need to watch them, you still need to supervise them. And what infrastructure as code does is provisioning and deprovisioning, not the ongoing operational control. The Kubernetes operator does a much, much better job at that, but it has to be a mature operator. So at least level 3, I would highly recommend go for level 4, level 5 when you can get it, right? Because now more of that operational stuff is being handled by the software if you like the way the software does the operational work. Okay, and again, you give up some control. You can't do all the extensions, etc., if they're not supported by the vendor that provides the operator and the containers. When you go to DBaaS, it's going to be truly as a service on demand, right? We all know it from whatever cloud we're using, Alibaba or Google or Azure, etc. It's on demand. You click, 15 minutes later, you have a new database or a new database server. They're all broadly network accessible, so there's really no difference. They all run on public clouds, so that's really not a big deal. The resource pooling is not really defined on virtual machines. I mean, in virtual machines, yes, the underlying servers, there's a very large pool for you, but in terms of database resources, you're still in charge of provisioning more, provisioning less. So the pool that you have currently available is defined by what you have configured. Kubernetes does a little bit of a better job there because inside of a pod, it has the ability to do a better job of using the available resources as a pool. It has with anti-affinity controls, etc. It has better ability there built in to make good use of that, right? And then obviously database as a service, well, that's you have a virtually endless pool of resources, virtually, whereas we've also found the situations where that's no longer the case, where you're running out of a certain machine type or something. And then the rapid elasticity. In VMs, again, you're in charge, right? If you want to scale up, scale down, you have to do that manually or with infrastructure as code. The operators in Kubernetes will help, right? Because a mature operator can do scale up and scale down. We'll support that out of the box. So again, that's a lot easier, but it's really a strength again of the DBaaS environment. Measurement, the same thing. Only the DBaaS gives you a true, complete measurement of all the resources that you have consumed. In the other environments, yes, the operator will provide some database metering, but not necessarily of the underlying hardware, network, storage, etc. And then on infrastructure as a service, again, you're relying on whatever the platform provides, and the platform in this case provides infrastructure, meaning it has very limited visibility into what your software is actually doing. Okay, so again, it's a guideline to figure out where you're going to go depending on what your reasons are to go to the cloud at all. And then, as Bruce said before, we've kind of outlined the trade-offs a little bit here, and with VMs on infrastructure as a service, you have full control. I mean, it's just another data center, right? You can SSH into the machine. You have ultimate configurability and tuning. You can install any extensions and versions that you want. You do get the highest performance and the lowest third-party cost if you do it that way. But you're responsible, okay? And that's really, really important, because if you want to configure at the operating system level, you can, but you also need to know what you're doing, right? You have access to all the hundreds, I think it's 357 GUCs that Postgres provides for you. But if you don't know how to use them, well, it has no advantage for you, right? So the things to consider are you are now in charge, which is good and can be bad, okay? Gives you ultimate control, but also ultimate responsibility. Kubernetes takes that to the next step, right? The operator does a lot of stuff for you. The upgrades, for example, are done for you, and they're under your control. So you can decide, do you do them? Do you not do them? When do you do them? Right? Which version do you want to use, etc. Okay, but the trade-off to consider is you got to go Kubernetes, right? You don't go Kubernetes with the database if the application is not going to a kind of microservices type of thinking, because Kubernetes has its greatest advantage when you can control the whole stack that way. Right? When the whole deployment, the whole management, the whole monitoring, the whole life cycle is under control of Kubernetes. Right? And then don't be fooled. Even in Kubernetes, you need to understand how the infrastructure works. You've had a number of customers who blindly got into Kubernetes thinking, oh yeah, it's going to take care of everything for me. No, you're still in charge of the infrastructure. Now it's a Kubernetes infrastructure, but you're in charge. And when you go to the managed database service, now you have a service reliability engineering team that monitors and operates, which is great, or can be great, right? They apply the upgrades. But if they don't apply the upgrades, there's nothing you can do. And as of last week, still, I have not looked this morning, there were database services out there who are over 2 years behind in applying upgrades for Postgres. So be very, very careful. Yes, you relinquish that control. You don't have to worry about the upgrade, but If the upgrade doesn't happen, there's nothing you can do because it is a service and you have to trust the service provider to do it for you. Now, you can't do operating system tuning and you don't have to do operating system tuning, right? The database extensions, many of the providers support a very long list of database extensions, and that list is always growing. But if your extension is not on that list, you can't use it. So Bruce, anything you want to add to that?
No, I think you really covered it well. We're not really here to sell anything in this webinar. We're just really here to kind of explain what this landscape looks like, where we see the industry going, and how, what kind of criteria you should use in trying to figure out, do you go to the cloud? And if you go to the cloud, which of the 3 deployment methods do you use? And as we can see from the poll, everyone, it looks like people are making different decisions based on what their requirements are. And your organization has to sort of figure out where you're going. I remember being in organizations years ago, and there's that one meeting where you sit in the room and everyone decides, are we going to the cloud, or are we going to, in our case, are we going to client server back in the 90s, right? Are we going to Windows from VMS or whatever? And yeah, you're going to have that meeting, and you're going to have to look at these things and say, yeah, this is the direction we want to go as an organization. And you have to also ask, how does that affect me personally as an engineer, right? Is this where I want to go? What skills do I need to have? How do I continue to provide value to my organization in in an important way? And that's a question you should always be asking yourself.
Yeah. Yeah. Okay. So okay, and then there's some key considerations when you move to the database of the cloud that kind of that always apply. And Bruce, you want to talk through this?
Yeah, this is basically a list of some things to think about once you decided kind of which one you're going to, right? You've already made that decision. How do you operationally kind of work at that? So I wrote a blog on the EDB blog site there at the bottom if you want to read it and kind of get more detail about what exactly some of the concerns are. But again, uh, you know, how are you going to deploy your database? What if you're going to use, if you're not using a service, right? Are you going to use Ansible, Puppet, or Chef, right? Are you going to use containers? Are you going to use Kubernetes on top of containers, right? These are decisions you have to make. And then operationally, how am I going to get my data to the cloud, right? A lot of cases we're talking about gigabytes or terabytes of data. How am I going to get it in there? Am I going to use replication? Am I going to have 2 Postgres next to each other? I'm going to replicate into that cloud architecture. And then once I'm ready to switch from my in-house to my cloud, how am I going to do the switch over, right? And then how am I going to handle downtime? And of course, I probably am not moving just my database. How am I going to handle middleware? How am I going to handle the monitoring that I'm currently doing in-house? My load balancing I'm doing in-house. My failover backup I may be doing in-house. How is that going to work in the cloud? Or you have to, unfortunately, all that stuff has to happen in that move. You can't just sort of move it and then come back later and say, oh, worry about backups in a week, right? You have to have that ready as you do it. Or if you choose a DBaaS, do you know that the DBaaS has all of the features and supports all the extensions and has all the flexibility that you need? As Mark says, does it even have the version of Postgres that you need, that your application is designed for? And this is a really tough one. How do you determine how many resources to give? Like, you have a whole bunch of machine types, different memory sizes. You can do provision to IOPS. What numbers do you use? I know you got to set up a test environment almost with an actual workload, so you can, before you actually go live in the cloud, that way that VM is configured, or the way you've allocated resources in the DBaaS, that it's going to be able to handle your workload, right? I mean, these are really tough really tough questions.
Yeah.
And then finally, how do you get your data out? Because a lot of people don't think of that one. And I will tell you, the database providers, cloud providers, make it very easy to get your data into the system. Some of them make it very hard to get it out.
Mhm. Yes, yes, that's definitely something, when you, let's say you would use RDS Aurora. It's a lot, very easy to get data in, but replicating out of Aurora somewhere else, that's a different story. So again, yeah, Bruce, that's those are absolutely the right things to do. And regarding also the machine types and storage, etc., the performance characteristics are different. So again, evaluating whether you will get the right performance with the same configuration, etc., is important.
Yeah, I mean, cloud is really good at resource sharing of CPUs and memory. They are not great at it's very hard to resource share IO.
Yeah.
So that is usually under provisioned. And unfortunately, most databases are very IO IO constrained. So in a lot of ways, it's the IO you have to often worry about first when you're provisioning. Then the memory. Then now you can do some trade-offs. You can bump up the memory, and that'll increase the cache size, so you don't need as much IO sometimes. But if you have a very hot, write-heavy workload, you're still going to need a very a good IO pipeline, and that can be expensive because it is very hard for the providers to share IO bandwidth in an efficient manner, because the IO, you're typically waiting for the IO to complete, and that doing that in a shared environment is pretty hard. The other thing I should have pointed out is the last bullet, getting your data out of the cloud. You have to find out how to get your data out of the cloud, but you also need to factor in how much it will cost to get your data out of the cloud, because some of the providers have very unusual cost, network cost calculations, where putting data into the cloud is very inexpensive, but taking data out of the cloud is very expensive.
Yeah. Yes. So the ingress charges and egress charges can be very, very different. Yes. Yeah. Okay. So just in summary, there are multiple ways to go to the cloud, and they're all applicable. It really depends on going back to the beginning and saying, why am I going to the cloud? What am I trying to do? And that will actually tell you which of these paths you should be using, right? This is not a technology discussion. This is really, what is the right fit for purpose? So you can't really decide if you're not clear about why you're going to the cloud. Understanding pros and cons and the trade-offs is really, really important, okay? And understanding, I can have more control, but do I want more control? Am I willing to invest the skill set necessary to take advantage of the control? Because if you have a badly configured VM, you can configure it better than a DBaaS, but if you don't know how to do it, then don't try, right? Okay, but if you have the skill set on the bench, the world's best Postgres DBA who really knows how to make Postgres and the VMs dance, well, take advantage of it, right? But again, that really depends on what you're trying to do. So let's get to our questions here. So Crystal, what do we have?
Yes, we had a couple of questions come in. We'll start. The first one came in on slide 11. And the question is if you can speak more to the cost of the options and kind of what people can expect in terms of return on investment for those resources.
I think we covered that in the later slide. I think there's two answers. The one is that obviously every DBaaS has a different cost. So you're going to have to look and again, it's going to be the DBaaS, it's going to be the cost of IOPS on the DBaaS, it's going to be the cost of getting data out of the DBaaS. There's a whole, spectrum of things you have to look at. So I don't know that. I mean, in ballpark, I've heard 2x between DBaaS and VMs, but that's a very crude number. But I think in terms of ROI now, in the later slides, I think it was slide 14, where we started talking about, okay, I'm paying for VMs or I'm paying for DBaaS, maybe, but what am I saving? What additional capabilities am I giving my organization? What flexibility am I giving my organization? What addition improved user experience am I giving my organization? And then ultimately also, what salaries am I going to be able to eliminate by
Yeah.
doing this, right?
And that's, I think, a key thing that I want to make it very clear here, that when you bring your database to the cloud, do not get rid of your DBAs, okay? Because, I mean, you can mask a badly written query by tripling your CPU and buying IO till the cows come home and going to Aurora because, the query's so slow. Yeah, a good DBA might look at it for a half hour and say, let's just do this and this and this and index here and boom, and suddenly your cost is dropped, okay? It's in my view, one of the key reasons why companies complain about cloud cost is because it's so easy to mask inefficiencies in the code and in the implementation by just throwing more machine resources at it. We have customers who tell us the same stories about Oracle RAC. That Oracle RAC is used to mask coding problems. In the cloud, the same thing happens. So when you do this, right, don't think that, oh yeah, I'm just going to put all my queries in the cloud and they'll just perform. They won't. You still need the expertise to make sure that your data model is right, your queries are right, that you have indexes in the right places, etc. That is still needed. Okay. And often when we hear that, oh yeah, but on VMs it is so much better, it is because on VMs it's not that the VM is better, but that the team and the capabilities that were associated with the project are better than somebody that says, oh, I'm just going to go to a cloud service. I don't need no DBA. That's a big mistake.
Okay, excellent. We might have time here for just one question, one more question, which came in on the next slide, slide 12, and that's how about data access security in database as system environments?
Well, when you look at it, right, it all starts with encrypting what's on the wire, right? They all support that, SSL on the wire. Many of them now make the VPC or their VPC equivalent something mandatory. That's the standard where they start. So as far as security goes, I know years ago there was a big concern that going to the cloud was actually an issue with security. Today, I would say that most cloud operations, at least the big ones, are at least as secure, if not significantly more experienced in terms of security than on-prem operations. So I think all the tools are there to do that today. There's role-based access control, all the security configurability. There is on-disk encryption, in-transit encryption. Those things are there. I wouldn't worry so much about security anymore. Or Bruce, what are your thoughts about
No,
that?
I think you're right. I'm looking at some of the chat questions. There's a lot of really good questions in here, really relating to Kubernetes. Are we talking about a standalone Postgres in one container? They're asking about, there's a lot of really good questions in here. It's almost like we could have our own webinar just on the questions.
So I think what we'll do is, we will do that anyways, is we'll take all the questions, we'll try to answer as many as we can as part of the email that's going to go out
That's a good idea, yeah.
As a follow-up with this webinar. Can't promise that we can answer them all, but we'll try really hard because we're out of time now, I think.
Yes, we are. We're just at the top. So much to your point, Mark, we'll get as many answers into that follow-up email to all of you. And that will include the recording along with the slides as well. If there are any additional questions, please feel free to reach out. Otherwise, thank you for joining us for our webinar, and we hope you have a great rest of the day. Thanks, Mark. Thanks, Bruce.